Done, sir.
Very good. So here we are done with the preparation of haloalkanes from alcohols. Now we will move to the second types of preparation of haloalkane, and that is the second part is from hydrocarbons. From hydrocarbon. The first preparation method is from alcohol and the second is from hydrocarbons. And in hydrocarbon, we have another subpart that is from alkanes, by free radical halogenation. From alkanes by free radical halogenation. So basically, this is the subpart of hydrocarbon. Now it's very easy. You have already studied this halogenation reaction in class 10th as well, and class 11th as well. You know, if you have CH4, this is your hydrocarbon or alkane, methane, and if you are going to react this with halogen, let's say there is Cl2, in the presence of sunlight or HNO, you know what will happen? One of the hydrogen will be replaced by chlorine. So initially it has 4 hydrogen. Now it will have 3 hydrogen, and one hydrogen's place will be replaced by chlorine. And as a byproduct, one of the hydrogen from here and the chlorine from here, this will be our byproduct. So basically, this is the main product. We were preparing haloalkane, so you can see, or alkyl halide, methyl chloride or chloromethane is here. If you have a reactant like this CH3, CH2, CH2, CH3, and if you are going to react this with Cl2 in the presence of HNO, you know, first of all, different types of hydrogen. You can see how many carbon is there. 1, 2, 3, 4. 4 hydrogen, 4 carbon is there. Now you need to replace one hydrogen from each carbon separately and replace that with hydrogen. Sorry, replace that with chlorine. Let's say if I'm going to replace first hydrogen with the chlorine, it will be this, and the rest part will be as it is. If I'm going to replace the second hydrogen of carbon, you can see it will be like this: CH3, CH, and here it will be Cl, and again CH2, CH3. Then comes your third carbon from the left to right, CH3, CH2, and the third carbon will be like this. And the last one, CH3, CH2, CH2, and this will be CH2, Cl. Now see what happens here. Basically, if you are going to write the IUPAC, this and this both are same. This and this both are same. If you will write the correct IUPAC, you can see this is your chlorobutane and this is also your chlorobutane. And if you have obtained more than one product which has same IUPAC, that means they are identical. And this will have name 1, 2, 3, 4 and 1, 2, 3, 4. This second and third product is 2-chlorobutane. 2-chlorobutane. And this has name 1-chlorobutane. So all I want to say is that draw all the possible structure and then write the name. If you when you will practice a lot, then you will be able to understand just looking at the question that which how many product is there. So only 2 product is there. Only 2 product is there. 2 products in which this is your major, this is your major because it is secondary halide, and this is your minor. This is your minor. I think you have got it. If you haven't, just let me know.
So why is it major?
Major, it is secondary, it is primary. Basically, if you will, whenever there will be question on the basis of, whenever there will be question uh, for stability, go for symmetry, or you can see the symmetry is more on secondary than primary, right?
Yes.
So that's why. Let me know when you're done with this. Are you done with this?
Done, sir.
Very good.
Yes, sir. Done.
Now see, if I'm going to give you, draw all the possible product for this. Draw all the possible product for this. Are going to react this with Cl2 in the presence of H nu. Very good, Austin. Humam, any answer? So Humam, you need to replace this hydrogen with chlorine, this hydrogen with chlorine, and this hydrogen with chlorine. So if you are going to replace that with chlorine, This is the product and its name will be 1-chloropropane. 1-chloropropane. And if you are going to replace the hydrogen from the in between carbon, it is 2-chloropropane. 2-chloropropane. And for the last one, CH3, CH2, CH2, again Cl. So it is also 1-chloropropane. So basically you can see the first and third are same. That means they are identical and hence only two products, this and this. Very good, Austin. Mom, are you done with this?
Yes, sir.
Okay. So this is very basic. The second preparation, first preparation of method from hydrocarbon. The second preparation of method from hydrocarbon is your, this has, the second is R from alkenes. From alkenes. And here you can see from, if you are going from alkenes, it is also divided further. The first one is our addition of hydrogen halides. Addition of hydrogen halides. That means basically, you know that alkene is a hydrocarbon. But here, when you are going to add hydrogen halides to an alkene, then it will give you haloalkane or alkyl halide. Let's say C, double bond C. It will be like this. And if there is HX, then you know what will happen. This bond will be broken and hydrogen will be attached. Hydrogen and X will be attached at any one of the carbon. Either X will attached on left or right, because this alkene is symmetrical. This alkene is symmetrical. You can see symmetrical. That means if you are going to break this double bond, then what will happen? The left and right side are equal to each other. Yes or no?
Yes.
So whenever a symmetrical alkene, like let's say CH2 double bond CH2, and if you are going to react this with HBr, you know what will happen? First, you need to know, if you are going to break this between two parts, you can see the left part, it will be image of the right part. Basically, they are equal. So this is symmetrical. So in symmetrical alkene, whether you are going to add hydrogen to left or right, it won't affect. Both are same. But in asymmetrical alkene, it will be affected. So this is the first part for symmetrical alkenes. I will explain the symmetrical alkenes as well. First, write it. Both of you done with this?
Yes, sir.
Okay. Now, when we talk about asymmetrical alkenes, let's say, I'm just going to write it here. Listen to me very carefully. It's very important. You have studied the same reaction in class 11th, asymmetrical alkene. Now, there is two possibilities. The first one is if you have an asymmetrical alkene CH3, CH2, double bond CH2, and you are going to add HX or HBr, let's say, like this. Now you can see if you are going to break the bond from here, the right hand side will not be equal to left hand side, and hence it is asymmetrical alkene. Now, if the reaction is like this, when an asymmetrical alkene is going to react with HBr only, then this reaction is known as Markovnikov. This reaction is known as Markovnikov. Markovnikov reaction. When an alkene is going to react with HBr, only HBr, there is no reagent Markovnikov. Now, what does this Markovnikov says? This now Markovnikov says that negative part will go to that carbon. Negative part will go to that carbon which has greater number of hydrogen, which has greater number of hydrogen and positive part will go to that carbon which has lesser number of hydrogen, which has lesser number of hydrogen. Just wait a minute, please. Which has lesser number of hydrogen along double bond. Long double bond. Now see what happens here.
So
Yes,
negative goes to the less number of carbons, right?
Wait a minute, wait a minute. Negative part will go to that carbon which has, oh shit, so sorry, has less number of hydrogen, and positive part will go to that carbon which has, yeah, greater number of hydrogens. And thank you, very thank you. See, what is this negative and positive? So we know that the bromine is more electronegative than hydrogen, so it will have negative and this will have positive. So this negative part will go to that carbon which has lesser number of hydrogen, and positive part to that carbon which has greater number of hydrogen. One of the bond will be broken. One of the bond will be broken. So the product formed here will be, you can see CH3, and here it will be CH, and here it will be CH2. Now the Br will come to the carbon which has lesser number of hydrogen, and hydrogen to that carbon which has greater number of hydrogen. So it's very simple. Whenever you are going to do the reaction, you should first recognize the reaction. Like if this reaction is given to you, like any alkene given to you with HBr or HX in no peroxide or nothing, then it is Markovnikov, and you can apply this negative to the less number of hydrogen and positive to the right number of hydrogen. Please do write it. Let me know when you are done. Both of you done with this?
Yes.
Yeah, yeah.
Very good. Now you can see that if the same reaction is carried out, only the difference is that this alkene react with HBr in the presence of peroxide. In the presence of peroxide, that represents it is anti-Markovnikov. It is anti-Markovnikov. And you know, Markovnikov is opposite of anti-Markovnikov, or you can say anti-Markovnikov is opposite of Markovnikov. So this is your negative, this is your positive. In Markovnikov, negative part will go to lesser number of carbon. So in anti-Markovnikov, negative part will go to that carbon which has greater number of hydrogen, and positive to that carbon which has lesser number of hydrogen, and hence the product will be, you can see, first of all the double bond will be broken, and hence the hydrogen will come here and bromine will be here. So isn't it easy? Let me know when you are done with this. Let me know when you are done with this.
Yeah, done.
Hmm. Now I'm going to give you a question. Humam, you're also done with this, right?
Yes.
You are able to see the screen, right? Please do it. Any answer? Please do let me know if you are done with this. Are you done with this? Austin,
Yes, sir.
are you done with this?
Yes,
Yes or no?
yes, sir.
Okay. So see what happens here. You can see there is an alkene. Don't go for this. Just wait a minute. I'm gonna give you. So see, I'm going to explain the first one. See, this is your benzene group. Benzene group. Benzene, that means aromatic. Aromatic are extra stable. You are not going to break the bond, double bond in aromatic compound. So it will be as it is. They are very, very stable. So you're not going to break the benzene bond, double bond in this. Okay. Now you can see there is double bond. Now you can see HBr, alkene with HBr, that is Markovnikov. So if it is Markovnikov, the bond will be broken and the rest part will be as it is. There was as it is. Now since it is or Markovnikov, this is your negative and this is your positive. Negative will go to that carbon which has greater number of hydrogen and this will go to that carbon which has higher number of hydrogen. So bromine will come here and hydrogen will be here. This is your Markovnikov. So if you recognize the reaction, it is very easy to do. Now the next is you can see HCl and CH double bond asymmetrical hydrocarbon alkene, asymmetrical alkene. The next part you can see HCl and in the absence of peroxide, so this is also Markovnikov. So the rest part will be as it is CH3, CH2, and CH, it becomes single bond CH2. Again, what you need to do, very simple. This is negative, this is positive. Negative will go to that carbon which has lesser number of hydrogen. Positive will go to that carbon which has greater number of hydrogen. So you can see hydrogen will come here and chlorine will be here. The next reaction you can see, this is also asymmetrical hydrocarbon, but it reacts with HBr in the presence of peroxide that makes it anti-Markovnikov. That makes it anti-Markovnikov. Now you can see if it is anti-Markovnikov, negative part will go to that carbon which has greater number of hydrogen, and positive part will go to that carbon which has lesser number of hydrogen. And you are not going to do anything with this because it is aromatic compound, highly stable compound. Okay, so the benzene will be as it is, and the rest part you need to change is this. Hydrogen will come here, and hydrogen will also, the hydrogen I just wrote it here. Just wait a minute. Now what you need to do, it's very simple. See, hydrogen will come here, and then CH2 bromine will come. This is your anti-Markovnikov. I think it's clear to you. Yeah, the name will be sub branch as well. You can go for uh, 3 bromo propyl benzene. This will be the main chain. So this will be your one, and here it will be 1-2-3 3 bromo propyl benzene.
Yes.
Homam, are you done with this?
Yes, sir.
Now see the next part of this from alkenes we are going to do. It's very simple. The B part from alkenes, that is addition of halogens. Addition of halogens. This is part of alkene. That means you are directly going to add halogens into halogens to alkene. So if you have any alkene like this, and you need to add halogens directly, so there is a reaction. You are going to add Br2 in the presence of CCl4. You know what will happen? The bond will be broken. Br will be equally divided. So hydrogen was there. There was also hydrogen and hydrogen. Now one of the bromine will come here at adjacent position, and that's why vicinal or vis dibromide. Let me know when you are done with this. Mom, are you with this?
Yes, sir.
Okay. Moving to the before next question, I'm gonna give you a mm, question which is very important and very easy. Identify all the possible identify all the possible monochloro all the possible monochloro structural isomers expected to be formed on free radical free radical monochlorination of CH3 whole twice CH2 CH3 monochloro product. You need to identify how many monochloro structural isomers can be extracted from this formula. Very easy it is. You need to react with possible products. Any product, you just need to replace hydrogen and check it. Let me know if you are not able to solve this. Am I audible?
Yes, sir.
Okay, are you able to solve this?
Yes, sir.
Okay. You are taking too much time. Let me explain. First, what you need to do, first open this structure and then write like CH is as it is, then CH, then CH3. And this will be CH3 and CH3. Now, if you are going to react this with Cl2, monochloro product, monochloro, that means single chlorine. So I'm going to replace this, the first one. The rest one will be as it is. So it will be CH3, then comes your CH2, then comes your CH2, Cl, the first product. If you are going to react this with Cl2, now see, I'm going to replace with this. Now this hydrogen, so what it will be CH3 and then CH, then your CH3, and then your CH and Cl will be here, and this will be the second product. Now I'm going to change this with this one. So what it will be CH3, then CH3 is here, chlorine is here, and CH2 and also CH3. Now what we need to do is very simple. You are going to replace with this one or this one. Both are same basically. So what it will be CH3, then it will be CH, and there will be CH2Cl, and the rest part will be as it is CH2, CH3. So how many products I have drawn here? You can see 1, 2, 3, 4 products, 4 possible products. Monochloro product, very easy. Please do write it and then let me know. Let me know when you are done with this.
Yeah, done, sir.
Very good. Now see, we have the next method to prepare haloalkane is our halogen exchange. This is the third preparation, halogen exchange. And in halogen exchange, there are two named reactions. The first one is I'm going to show you. The first one is Finkelstein reaction. Finkelstein. And how you are going to recognize Finkelstein reaction. So what happens when this is especially for alkyl iodide. So I'm going to write a point about this. Alkyl iodides is what? Alkyl iodides are prepared, basically especially prepared for just a minute. Please wait. Am I audible, both of you?
Yes.
Okay. So alkyl iodides are prepared by the reaction of alkyl chloride. Either you are going to react this with alkyl chlorides or alkyl bromides with sodium iodide, in dry acetone. So basically what I want to tell you is that if there is an alkyl halide, you need to react this with sodium iodide in the presence of dry acetone, So what will happen? There is halogen exchange will take place. So this will go to this and this will move to this. So you will be getting Ri plus NH. So this process is basically especially to produce alkyl iodide, and here X is only equals to chlorine and bromine. To write it. Let me know when you are done with this. Are you done with this?
That's
Okay. The next part of this, which is also a named reaction, is Schwarz reaction. Please do write this with me. Schwarz reaction. Now, how do what is this Schwartz reaction? This is especially for alkyl chloride. This is especially for alkyl chloride. So I'm going to write the synthesis or the preparation of alkyl fluoride by heating an alkyl chloride or bromide. Same alkyl chloride and bromide in the presence of only the reagent changes. In the presence of metallic fluorides, presence of metallic fluorides such as AgF, metallic fluoride like Hg2F2, COF2, or SbF3, antimony trifluoride. The reaction is termed as Schwartz reaction, and the reaction you can see either it is CH3Br or CH3Cl. You are going to react with metallic fluoride, then halogen exchange will take place. This will be replaced by this, so it will be CH3F and AgBr precipitate out. So this method is especially to prepare alkyl fluorides. Let me know when you're done with this. Both of you done with this?
Yes, sir.
Okay. Now I'm going to give you reactions that I just taught you from NCRT. Very easy. Please do write the product. Take your time. I'm giving you 10 to 12 minutes. 10 minutes is more than enough. Please write the product for each of the following. Are you able to solve this, Austin?
Doing so.
Humam.
Yes, sir. No, sir, I didn't.
Okay. See, this is preparation of haloalkane from alcohol SOCl2, the last one, the best preparation. You just need to replace this and you will get this, the main product. Now see again, this HCl. This OH will be replaced by Cl. You cannot replace this OH because it is in conjugation with so, conjugation with benzene ring. Benzene ring. It will there will be resonance. That's why, and hence the product will be. You can see the benzene will be as it is. OH will be as it is, and this OH will be replaced by chlorine. Now this is your Finkelstein reaction. In the presence of dry acetone, it will be CH3CH2I. Now, when this is your halogenation, halogenation, halogenation. So halogenation takes place in alkane. So Br will replace this or this hydrogen, this or this hydrogen. The rest part will be as it is. NO2. NO2 is there, and you can replace one of the hydrogen from here and another product for this. As you can see, it will be like this and this. Here, the major product, we always need to prepare the major product. This is your major product, and hence this is the main product. This is the minor product. Minor product. You can see this is your 2 degree and this is your 1 degree. Now the next, you can see HI and there is double bond. So there is no peroxide. That means this is your Markovnikov. And what does Markovnikov say? Negative part will go to that carbon which has lesser number of hydrogen, and positive to that carbon which has greater number of hydrogen. Just break the double bond and then you can see CH3, and this is your I. Hydrogen will go to this carbon. And the last one, Br2. This is your, again, the halogenation reaction. Halogenation reaction. So the product, you are not going to break the double bond. Product will be this major product.